Welcome to the NanoLumens Visualization Center. With me today we have Gary Feather, CTO of NanoLumens.
Well, it's great to be here today.
Gary, you joined 4 or 5 years ago?
I did. I was with Sharp Corporation, LCD televisions, all kinds of masterful display quality issues, and wanted to really move back into the large area display industry that it was in many,
You had
many
quite
years
a
ago.
long history at Sharp?
I did. I was at Sharp for 17 years,
Wow.
a couple years in lighting, LED lighting, a brand new evolution in lighting, and as you can see today what that has done. And then a lot of time in LCD television, display quality being the most important thing. But as with Sharp, when we converted from CRT to LCD, and then on to build the large business that we see in LCD today.
Right. What attracted you to NanoLumens? I mean, they're probably quite a well-known company 4 or 5 years ago, but was there one particular thing that you liked about them?
Well, I think it's my history. I was with Texas Instruments before I went to Sharp,
Okay.
and we developed a DLP chip. Digital light processing, a solution with micromirrors on a chip, changed the display industry forever.
That won an Oscar for technical achievement.
It has. 2 or 3 other Oscars have been won with regard to some of the cinematic adaptations have been made to how the chip functions to create the story well told for cinema. So with that in mind, to get from the large 90-inch screens, which Sharp had, and moving into the super large 100 square feet, 1,000 square foot display again, exciting opportunity to move ahead and move back into that.
Okay. So when you joined, LED and cinema probably never mentioned in the same breath, but now we're talking about cinema. Let me just ask you that question. Is there a place for LED in the cinema industry?
Well, absolutely. Every display technology starts basically being something that looks like a sign. It just turns on and off. And then you start getting grayscale and performance and motion adaptation. And so digital signage has done the same thing. When we talk about LED, we almost always think digital signage, big displays outdoor. And now what we've moved to the indoor, and that's gone quite well. And now people are looking for not a sign, but a true video display.
Okay. So it will happen, you think?
Well, absolutely. We have a metric right now. We can look at the LCD and the OLED televisions that are out there.
Yep.
And so sometimes when you're working on a technology, you wonder, where do I want to get in this technology with regard to performance? So we see those displays, and those are still milestones not yet met by LED displays.
Right. I was going to say, with your background with Texas Instruments, there must be so many different governing bodies for cinema to get the right standards.
Well, foundationally, SMPTE is really the age-old group that's there that allows the industry to come together, pool their needs, and get one body of people to reach a consensus on what has to be made.
Right.
When we did DLP transition, we moved out of film, and that was such a huge dislocation. Still projection, but no film, and some people said it'll never work.
Right.
But by cinematographers...
Was there a length of time it took for that to happen?
Yeah, the technology was developed in the 90s, so first launch of real products was in 1995. The first large area display, a 2048 by 1152 display, was in 1998.
Right.
And then Steven Spielberg got heavily involved in it. 2 years later, did the first cinema-based application with DLP. Today, there are 166,000 DLP cinemas in the world. So between then and today, about $21 billion worth of cinema products were sold by TI and the related companies to replace film and put that in a really interactive theater environment.
Okay, and to put you on the spot again, then, you really think that will happen with an LED product at some point?
Well, let's be clear on that. It's going to be a different product.
Okay.
So LED for an outdoor sign is not LED for an indoor display.
Okay.
That's clear.
Yep.
It's trying to create a different effect.
Right.
It also can't be as bright. When you move from an indoor display to a cinema, you might say, well, it's the same thing. It's not.
No, okay.
So a typical indoor display that the industry would sell for LED is going to be about 1,200 nits. You don't want it so bright that it takes over the whole room, but you don't want it so dim you can't see that. And so 2,000, 1,200 nits, that range is what people were doing for indoor. Now people are moving into the 1,700 nit displays, because the rooms are not as bright and you don't want the display to take over the whole space. A television set's about 300 nits, so that gives you an idea what that is. So what do you think a cinema brightness is today?
Couple of thousand?
You might think that.
Yeah.
Right. 48 nits.
Oh, okay.
That
Way
is
off.
the standard.
Right.
So is it a question they can't get any brighter than that? No, what they're trying to do is they have to create an environment where the pupil dilates completely. You get the full peripheral vision. The clothing in the theater isn't reflecting any more light, and you're able to be pulled into the image. If it was too bright, it's a lean back experience. So there are many dimensions like that that we could go through and talk about what has to change as I move from LED signs to LED indoor to LED in the cinema. And we're on the path working through those, as is many people in the industry right now.
That'll be interesting. Well, we look forward to some announcements maybe in the year ahead. The other thing that you can help me with is the chip on board. Now, this is a manufacturing process that people have explained to me, a journalist, many times, that I've not really understand all of it. I understand some of the benefits of brushing against something that's been built, chip on board thing, but explain to us, because you have a different approach to chip on board, I think, NanoLumens.
Well, we do.
Explain what it is first, perhaps.
All right, well, just go way back in time. In the 80s, I ran microelectronics facilities at Texas Instruments, where we took thousands of chips, put them on boards, wire bonded them, or flip chipped them, or thin film metallized them to connect a circuitry. So that basic technology has existed for a long time. So today, what we do for LED is we put 3 devices in a package, typically, and that's a cup or a flat package. We bond those parts out, and you fully test that part before you put it on a board. And in principle, that's a very good process. So you're creating little RGB light bulbs. Some people have gone to making 4 of those in a package, or a quad pack, because then I can get rid of a lot of the interconnect problems and others associated with this package. So again, pre-test it, make sure it all works. The reason you wouldn't normally just put chips on a board is you don't know that they all work equally well.
Oh, I see.
So you'd have to test them first and then scrape some off and put some new ones down. So your yield might be down. So as you pick a size of a module, the module will set on how you can set the performance of the devices and pre-test them and get them right. So that's the basic premise is forget the packages, the RGB SMD LEDs, skip the packages completely, put the parts directly on the module board that you have, and then interconnect those parts. There's multiple ways to interconnect them. You can use wire bonds, which would be the kind of an older style. You can use thin film metal, which is deposition, or you're able to flip chip them. You put bumps on the chips. Again, this is 30-year-old technology. You flip them over, and then they attach without any wire bonds. As you might guess, if there's no wire bonds and no other interconnect, it's all solid and together, it's going to be fairly rigid and very durable and reliable.
And that's the bit that gives you the durability.
Okay.
And your take on this is slightly different to others, perhaps, when you launch? Or?
Yeah, I think that from a perspective of what you do, going to much smaller modules is an important aspect of this to assure that you do get the yield and the reliability. Because if you have a board that's completely built and it's epoxy coated, today we repair LEDs when they go out. It's going to be very difficult to cut through the epoxy to get a die out and replace it. So you really have to have a strategy of throwing the modules away. And you might say, well, that's ridiculous. Why would I throw modules away? They're perfectly good. If you build a throwaway product, it's going to inherently be a lot cheaper. And when we build a product to make sure you can work on it, how many products do you see today? There's no user serviceable parts inside. Once we do that, that's when you can get the cost out of a product, because I don't need 29 screws to pull off a plate to get inside a box to support that. So that's the goal, is to build a monolithic module that's durable on the surface, that has a surface finish that fits the reflectivity we want, that is a solid display device. And again, if it fails, you replace it with another one. But it will be cheap enough to support that mentality.
Last question. What's as a CTO, you sit above all of the technology stuff, a helicopter above the engineering stuff. What's the most exciting thing that you think or see that NanoLumens is going to come up with in the next 6 to 9 months?
Everything we do at NanoLumens is part of working in an industry. We leverage other people with our ideas and our concepts to try to get them going. So what is coming? The current LEDs we use are entirely too bright. Their multiplexing is too high, so we're paying a lot of extra money for large chips to run at these multiplex level. So smaller chips at a lower multiplexing level, even moving to what we would call a quantum micro LED solution, will tune the devices to exactly the right frequency, so we won't worry about binning like we do today. The yield will be very high in anything that is functional, and the result of that implementation will be these much less expensive modules that'll perform as good as anything we have today in the industry.
Brilliant. Gary, thank you very much.
Thank you very much. Appreciate it.